Welcome back to our series on the explosion of mathematics, where we dig into the hidden math that, basically runs our world. Today, we're going to get into one of the oldest and honestly one of the most beautiful puzzles in all of math, the secret rhythm of prime numbers. So let's just kick things off with a huge question, a question that mathematicians have wrestled with for centuries, and it really gets to the heart of a big idea, the battle between order and chaos. All right, let's start with something you probably remember from school, the prime number. It's just a whole number that you can't get by multiplying two smaller numbers. Seems simple enough, right? But, and this is a big but, that simplicity is hiding something incredible. Okay, so the atoms of numbers. To really get why primes are such a big deal, you first have to understand what they do, and what they do is, well, they build everything. Here's a great way to think about it. Just like all this stuff in the universe is made of atoms, all the whole numbers are built out of primes. They are the absolute fundamental particles of arithmetic. You just can't break them down any further. And this is where it gets really, really cool. This idea is so important, it's called the fundamental theorem of arithmetic. Basically, it means every number has its own unique prime recipe. Take the number 99. Its recipe is always going to be 3 times 3 times 11. Nothing else works. It's like a unique fingerprint for every single number. So this elegant role they have as building blocks, it's actually been hiding a deep, ancient mystery. A puzzle that people have been obsessed with for thousands of years. I mean, just look at this list. When you write them out, they just kind of show up. There's no obvious pattern telling you where the next one's going to be. Sometimes they're really close, like 17 and 19. Other times there are these huge gaps. It feels completely random. And that apparent randomness has fascinated and frustrated mathematicians since forever, all the way back to ancient Greece. You have to wonder, is it all just noise? Or is there some kind of music playing that we just haven't learned how to hear yet? So the hunt began, a search for some kind of secret rhythm. And mathematicians, they weren't just looking for any pattern. They focused on a very specific kind of order. They started looking for what's called an arithmetic progression. Now that sounds technical, but all it means is a sequence of numbers that are evenly spaced. It's like looking for a steady drum beat in the middle of a bunch of noise. Could they find primes that marched along at a constant interval? And they did. They found them. Short ones like 3, 5, 7 are easy enough to spot. But then, with more work, they found longer and longer ones. And these were the first real tantalizing clues that maybe, just maybe, the primes weren't so random after all. The search really intensified. Once we had computers, mathematicians started finding crazy long chains of these evenly spaced primes. But finding them one by one just led to an even bigger question. Could you find a progression of any length? Is there some limit, or does the structure just go on forever? This timeline really puts it in perspective. We've known there are infinitely many primes for over 2,000 years. But it wasn't until 2004 that two mathematicians, Ben Green and Terence Tao, finally cracked the code. They proved something incredible about the structure of primes, and it was a truly monumental moment. And this is it, the Green-Tao theorem. What it proves is just mind-blowing. It means you can find a sequence of evenly spaced primes of any length you can imagine. You want a sequence 1,000 primes long? It's out there. 1,000,000? A billion? Yep. The theorem guarantees they all exist. So what? What does finding these infinite patterns actually mean? Why does this matter so much? Well, it completely changed how we think about the most fundamental things in math. It totally flipped the script. The old view was that primes are basically random, with a few rare patterns sprinkled in. The new reality? It's the other way around. Order and structure are guaranteed properties of the primes. It's baked right into them, even if it's really, really well hidden. So at the end of the day, this isn't about some new algorithm. It's about discovering a fundamental truth about how numbers work. It's a perfect example of what mathematics is all about, finding this incredible, beautiful structure in places where, for the longest time, all we saw was chaos. So coming from the abstract beauty of prime numbers, our journey now is going to take us to a much more tangible, physical kind of challenge. If you enjoyed this dive into the heart of numbers, and you want to see where this kind of thinking can take us next, you should definitely follow the Stayblocks channel so you don't miss out on what's coming. So in our next explainer, we're going to tackle the fourth article from the book, and this one is all about control. We're actually moving from the idea of finding hidden order to a much tougher challenge, imposing order on systems that are naturally chaotic, like the turbulent flow of air or water you see right here. We're going to dive into the math of control theory, which is basically the science of managing, well, almost everything, from keeping an aircraft flying right to managing the flow of a crazy river. It's pretty amazing stuff.
Hey, thanks for joining us. We'll leave you with this thought to chew on. The secret rhythm of the primes was hidden right under our noses for millennia. What else is out there, just beneath the surface, waiting for us to finally learn how to listen?